Today we cover derivatives of inverse trig, and this is more of an informational piece because we essentially just wind up with some formulas. And what I'm going to do is give you those formulas first. These are also on your derivative table. But let's say I wanted to find the derivative of the inverse sine of u. Now, we spent some time last year on inverse trig. At this point, I'm not doing a review of inverse trig. We may have to later on, okay? But that is all in your pre-calculus binder, and we will, as we need to, do some review of inverse trig. So just remember, though, this little sine to the negative 1 does not mean 1 over sine. Okay, it's talking about the inverse trig function. All right, and I can do some review of that later as we need to. The derivative of the inverse sine of u is 1 over the square root of 1 minus u squared times du dx. Now, what does that mean? This is, and you might want to put a box around this thing because that is the magical formula that we want to follow. I told you this is mostly informational. I may do a quick little proof here in a second to show you how we came up with this formula, but basically you follow the formula. For example, if I wanted to find the derivative of the inverse sine of x squared. Well, according to this formula that I just gave you, it says that this will be equal to 1 over the square root of 1 minus whatever u was. So my u is x squared, but we have to square it. So it's going to be x squared squared, which we know that's going to be x to the 4th. We'll get to that in a second, times the derivative of x squared. That's what that du dx means. It means find the derivative of u with respect to x. So guess what? We're pretty much done with this problem. What's the derivative of x squared? 2x. That is the same thing as 2x over 1, so it will come up here in the denominator. So I'll have 2x on top. On the bottom, I'm going to have the square root of 1 minus x to the 4th. Problem is done. What did I say? Yeah, numerator. I meant to say it comes up in the numerator. Sorry about that. So the derivative of x squared, it comes up here in the numerator, and then the bottom we just simplify, and that problem is done. Okay? So, how about the derivative of the inverse cosine of u? So the derivative of the inverse cosine is just like the one for inverse sine, only it has a negative 1 on top. It's still 1 minus the square root of 1 minus u squared on the bottom, and it's still du dx on top. Okay? So there's the derivative of the inverse cosine. And all of these are on your derivative table. Okay? And in essence, what you're doing is just following the formula. All right? I am going to give you a couple that might not be on your derivative table. I don't remember if these are on there or not. The derivative of the inverse cotangent of u is negative 1 over 1 plus u squared times du dx. That one's a little bit different. All right. The derivative of the inverse cosecant of u is really strange. It's negative 1 over the absolute value of x times the square root. I'm sorry, that's supposed to be a u. Absolute value of u. Well, if my marker would work, u times, and that's supposed to be a u as well, u squared minus 1 times du dx. All right. And while we're at it, we may as well go ahead and hit the derivative of the inverse tangent of u. That one does happen to be in your book. And the derivative of the inverse tangent is 1 over 1 plus u squared times du dx. So, the good news about all of these is you just follow the formula. 1 over 1 plus u squared times du dx. And I think the derivative, I'm not going to write it up here, the derivative of the inverse secant, that one's on your table, I believe. But essentially all you're doing is just following the formula. Let me do one more example. Let's say I want to define the derivative of the inverse secant of 5x to the 4th. Well, the formula that we just learned, that one's on our derivative table, so let me pause and get to that for a second. So here's the formula for the derivative. We'll just go ahead and add it to our notes while we're here. The derivative of the inverse secant of u is 1 over u times the square root of u squared minus 1 times du dx. And you'll notice the only difference between it and cosecant is in cosecant, the top is a negative 1. So if this is my formula, this problem is really easy. My u, in this case, is 5x to the 4th. So it's going to be 1 over 5x to the 4th times the square root of 5x to the 4th quantity squared minus 1 times the derivative of 5x to the 4th. And, of course, the derivative of 5x to the 4th is 20x to the 3rd. I'm going to come over here so I have more room. 20x to the 3rd will go in the numerator. I still have a 5x to the 4th down here. How do I square 5x to the 4th? Wouldn't that be 25x to the 8th? It is. That's back to Algebra 1. Minus 1. And yes, there is one more thing I can do to simplify, isn't there? As I look at this little expression right here, I can do a little bit of simplifying. I should have a 4 on top. These x's totally go away on top, and I'm just left with an x on bottom. So I'm going to have 4 over x times the square root of 25 x to the 8th minus 1. And there's your final answer. Like I told you, this is mostly informational and applying the formula. And we're going to stop there for today.